Example number 4 wants us to determine the slope and the y-intercept of each linear equation. And then they want us to describe its graph. So we have 2 questions here. We have our first equation, x plus y equals 2. And we have the equation y equals 2. And so what I've shown you up here is the slope-intercept form of an equation. Go ahead and write that down. Again, another review from Algebra 2. And let's just quickly go over what the slope-intercept form of an equation is. This form is called slope-intercept for simply because, look, M stands for the slope, and B stands for the y-intercept, hence slope-intercept. So these names kind of have meaning to them, and they kind of make sense. So when you write an equation in this form where you say y equals the slope times x plus the y-intercept, this is called slope-intercept. And that's why I say right here that the line whose slope is m and whose y-intercept is 0b. Okay, so what we're going to do here is we want to find the x-intercept, the y-intercept, and the slope. Can we find all 3 of these things for this equation? And secondly, over here, can we find those 3 things over there? All right, and I always like to graph these. Even though the problem doesn't say graph it, it's always great to have a visual representation of what you're doing here. So after we do a little bit of manipulation right now, I'm going to graph it as well so that you can have a visual there. Okay, so let's look at this, x plus y equals 2. Okay, what we need to do is we need to transform this or rewrite this so it looks like this. So it's written in what we call slope-intercept form. And basically all that means is that y is by itself, right? If you isolate y, then the rest of it on the right side is going to be automatically put in slope-intercept form. So basically let's get rid of, or let's isolate this y variable. It's quite simply, right? All you do is just subtract x from both sides. So y equals negative x plus 2. And just for the sake of this example, I'm going to rewrite this as y equals negative 1x plus 2. We normally do not write negative 1 there, but just for the sake of what I'm going to do right now, I'm going to, just so that you can see why I would do that and what it means here. Okay, so by looking at this, like mx negative 1x plus b plus 2, is it evident that we should be able to identify right now what our m is? Can't we see what our m is? It's the number in front of x, right? So our m right here is negative 1. Okay. Normally you don't write it like this, okay? We actually write it as this, negative x, but we have to know that in front of any variable, when there's no number there, there's actually a ghostly 1. Okay, so there's always a 1 right here. So I just wrote it here just for now, but no textbook and no exam we give you will ever write that. And actually mathematically, you should not write that as well. So I'm just doing it just for now, just so you know there is a 1 here. Okay, and then we should know what our b is, 2, right? So this is why this is really nice, because this gives us those 2 things. So let's just real quick graph this, and this is going to be really nice here, because graphing things in slope-intercept form is chill. Look, the last number stands for your y-intercept, right? So just go to 2, 1, 2, put a dot right there, and then this number gives us our slope. Well, we could always write slope as a fraction, so that's the same thing as negative 1 over 1, which means that I'm going to go down 1 and then to the right 1. Okay, if it's negative, you go up or down on top, and then on the bottom you go right. Okay, so we're going to go down 1 over 1, down 1 over 1, down 1 over 1, right? I mean, you can do this as many times as you want. Okay, and we'll go ahead and just draw a nice little line there. That's cool beans, and there's what our graph looks like. You don't need to graph it, I'm just showing you this. So this, to describe it here, first of all, we know what the y-intercept is, right? So there's the y-intercept, that's the point 0.02, and we know what the slope is. The slope right here is down 1 over 1, down 1 over 1, so it's going to be negative 1. Now, what about the x-intercepts? That's an interesting concept there. What about the x-intercept? Well, we can kind of see graphically right now, right, that this is the point 1, 0, this is 2, 0. So we can see that the x-intercept is 2, 0. But what if you didn't graph this? Do you know how to find the x-intercept, or for that matter, even the y-intercept, by just given this? Okay. If I said find the x-intercept and find the y-intercept, you should actually be able to find any x-intercept and any y-intercept of any function I give you in this class, because they always follow the exact same process. And let me just quickly go over that with you. So maybe here, let me just erase this real quick. So if you're ever asked to find the x-intercept, and it doesn't matter if it's for this equation, if it's this crazy one with the square root, it doesn't matter. You follow the same thing, because look, if you look at the x-axis, every single coordinate point on the x-axis has something in common. And do you know what that commonality is? Well, look, this is -1, 0, -2, 0, -3, 0, -4, 0, 1, 0, 2, 0, 3, 0. What does every coordinate point on the x-axis have in common? It has a y coordinate of 0. So if you want to find the x-intercept, all you do is you set y equal to 0, and then you're going to then solve for x. And look, if you would have to done that right here, if I set y equal to 0, look, pretend that this is 0, so x plus 0 equals 2. Oh, look, the x-intercept is 2. Nice. And what about for the other one? If you ever want to find any y-intercept of any graph, I will give you this here, because we're going to graph a lot of different things in this chapter and in chapter 2. Okay, it follows the same process every single time. Look at the y-axis. This is the point 0, 1, 0, 2, 0, 3, 0, 4, and then going down. 0, -1, 0, -2, 0, -3. What do all the points on the y-axis have in common? They have the x coordinate is always 0. So that means you would set x equal to 0, and then you would solve for y then. Okay, so just 2 general rules there that you should know, that if it says to find any x-intercept or any y-intercept, you should know to always set the x equal to 0 to find the y-intercept, and set the y equal to 0 to solve for the x-intercept right there. All right, now let's go over here. We have y equals 2. Oh, y equals 2. I think we covered that in the introduction video, or like an example 1 or 2 or something like that, where we should know by now that y equals 2 is the line that looks like this. 1, 2, and it's our straight line. I think I'll just use my straight edge here so that it actually looks straight. It's this right here. Okay, did you know that? You're supposed to. You should automatically know that. Oh, snaps. Actually, it's supposed to go up. Hold on. Let's move this up right here. JK. Okay, there we go. So it's y equals 2, not y equals -2. Right? Because this means that every y coordinate is 2. Look. 1, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, right? Every y coordinate is 2, so it's a horizontal line there. Okay, so let's answer these questions. What's the x-intercept? When will this cross the x-axis? Will it ever do a little touchy? No! So you would say there are no x-intercepts. Where does this cross the y-axis? Easy, right? The point 0, 2. And if you remember from our 4 types of slopes, what is the slope of any horizontal line? You should know this. 0, right? 0. So, and there's that example right there.